Here we go. Before I begin, I want to make it very clear, I'm not a physicist. I'm not an astrophysicist. I'm not an expert on comets and asteroids from any scientific perspective. And I'm going to use KISS principles in this presentation. So we're going to keep it simple. And it's meant, obviously, for a general audience and not a meeting of astrophysicists. So let's get started. Suppose the human race was in imminent danger of sudden extinction. Would we do anything about it? What if we knew exactly where the danger came from? What if we knew exactly what to do to dramatically improve our chances of survival? Would we bother? Would we do anything? Well, of course we would. Even if we had to spend countless billions and trillions of dollars, we would do something. And not just the United States, but all the countries in the world. But what if this probability was very small? Let's say 1 in a million, 1 in 10 million, 1 in 100 million. Getting back to my actuarial career, decision-making under uncertainty or life. How do we balance the unimaginable catastrophe versus the ridiculously small probability? That's a quandary. And in this case, on a more practical level, what if we knew this hazard would strike the Earth every 50 to 200 years, all the time, with enough force to vaporize a city and kill millions of people or worse? Now, how did the human race, the Western world anyway, first become even aware of this danger? When and why did we even begin to take it at all seriously? Well, let's go back. Let's go all the way back. Let's go back to the beginning of our story. Let's go back to Isaac Newton and the late 1600s. Newton was a recluse and hated any public exposure or debate or controversy. When Leibniz came out with his calculus and other discoveries at about exactly the same time, there was a huge public debate between the Leibniz and Newton advocates. Who found this first? Who gets credit? And Bill Tittle, gave us a little side talk on the old guard about Newton and the way he was. And who did Newton turn to defend him? His very, very, very good friend, Edmund Halley. Halley, no slouch himself, as we know, found Halley's Comet. And this is where our story really begins. Halley's Comet, discovered by Edmund Halley. He made one of the most incredible predictions in scientific history, especially adjusted for their limited knowledge at the time. He confidently predicted that his comet would return in exactly 76 years in 1758. The Chinese had been observing this comet already for at least 400 years. They knew its regular orbit and 76-year predictable and stable return period. Yet, when all the great scientists in London saw it show up right on schedule in 1758, it was a huge scientific and cultural event. And of course, just about the only backward colonial who was in London in 1758 was our boy, Big Ben Franklin, there with all the top scientists. So this apparently orderly and totally predictable clockwork universe where the orbits of the planets and the comets and the stars seem to work well for over 200 years. Tick, tock, tick, tock, tick, tock, tick, tock. Then 4 things all happened in the period from 1905 to 1908 to turn our view of the universe upside down. In 1905, as we know, Einstein published the Theory of Relativity, which turned Newtonian mechanics on its head. The next year, 1906, was the year of the San Francisco earthquake. In 1907 already, seismic devices had been installed all over the world. We had seismic devices to detect earthquakes all over the world. Then in 1908, quote unquote, something happened. Something happened in Siberia near the tiny hamlet of Tunguska on January 30th, 1908. Every seismic device all over the world detected a 6.0 earthquake over Tunguska. It would take over 20 years before they came even close to understanding what really happened. It was not until the 1920s that Kulik, a scientist, and a team of Russian scientists reached the site. Hundreds of square miles of massive trees in the Siberian forest snapped like matchsticks in a concentric circle. They searched for years to find the rock, to find a crater. They searched in vain. They did not find anything. This puzzled them. At the time, they did not realize at all it was an airburst. It never actually hit the ground. Now let's go over to Arizona. I'm going to go back and forth through a number of stories, and I'll try to keep it clear as to how I'm switching. So now we're going to go over to Arizona. There was a meteor crater in Arizona that's been there for a long time, and it was very much consensus that it was formed by a meteor impact 50,000 years ago, and there was a crater there. So there was a crater. The Barringer family, the Barringer Mining Company, was convinced that somewhere beneath the surface of this crater was a rock containing very valuable metals. The Barringer family drilled for years and years and decades in vain, almost bankrupting himself, trying to find the rock, trying to find the evidence. He could not have realized then that often, even with an actual impact, all or most of the original rock is either vaporized or melted. There was no there. Now, these two things definitely slowed the pace of human understanding of comet and asteroid impacts on the Earth through the first half of the 20th century. Now, I'm going to go into more detail now. With hindsight, we now know pretty much exactly what happened over Tunguska on June 30th, 1908. The large object exploded it wasn't such a large object, I'm going to explain to you, exploded about 5 miles in the air over Tunguska. The 6.0 earthquake was just the power of the ground shaking as a side effect. Think about that. Timing is everything. If this had happened 12 minutes later, all of St. Petersburg probably would have been vaporized and millions killed. The human race would have received a violent wake-up call from a hazard we paid virtually no attention to for the next 60 years. Let me try and make this more real for you and make it clear to you. Hurricanes come every year. We have hurricane seasons every year. Hurricanes with no landfalls or fatalities or property damage do not attract much attention, no matter how severe or powerful they may be. But storms like Katrina or Superstorm Sandy do. And to put an emphasis and underline on that, the 2005 hurricane season was one of the worst in history. There were 3 Category 5 hurricanes in 2005. There was number 1, there was number 2, we've all forgotten about them, and there was Katrina. And of course, we remember Katrina well. Back to the summer of 1908, it was called the Summer of the Midnight Sun. It was in all the newspapers. There was virtually no darkness 24/7 in London and most of Europe and other places way far south of normally getting the midnight sun. Again, to go to some of the science, from the best scientific estimate, the energy released in the Tunguska airburst was 3 to 5 megatons. That is roughly 200 times the Hiroshima bomb. 200 times the Hiroshima bomb went off 5 miles above the surface, above Tunguska, and no one was living anywhere near there. Now, the best estimates of the size of the rock that caused this was about 60 yards by 20 yards by 10 yards. Not a very large object. Think of it as maybe being the volume of 2 or 3 large rooms in your house. That was the size of what exploded in Tunguska. That is why every June 30th is Global Asteroid Day, more prominent every year. Here's some fun trivia for your classic rock buddies. Brian May, PhD in astrophysics, is one of the leaders globally for Asteroid Day, a global expert on asteroids and comets, and has also been lead guitar for Queen for the last 50 years. Great movie, Bohemian Rhapsody. You should see it. Now let's try to distinguish asteroids from comets and give you a little orientation. Asteroids come from the asteroid belt between Mars and Jupiter. There are a few million of them, and almost all of them stay in their lane, quote unquote, in the asteroid belt in a big traffic jam. It does not take much to disturb them and send them hurtling towards Earth. Now, comets live mostly in the Oort clouds. That is at the very edge of the solar system, much, much farther away than the asteroid belt, out where we think of things like Pluto and Neptune. There are countless millions of them, and they tend to stay in the Oort cloud or the Kuiper belt near Neptune. Now, the comets that do come near the Earth or the sun are long period comets. These generally are comets that don't come every year or every 3 years. The big comets might come 1 in 100 years or 1 in 500 years. Hale-Bopp in 1999 would be a good example of a long period comet that probably has a 1,000-year period. All near-Earth objects, of course, are orbiting the sun in orbits that can put them near, in, or on the path of the Earth. Now let's talk about 3 different types of asteroids, basically called silica, metal, and stony. Objects of the silica variety cause the least damage upon impact. The stony ones are the ones that dinosaurs don't like and nobody should like, no matter what their size. Let us now jump and briefly talk about meteor showers. We see them every year at the same time. The Leonid meteor showers in November every year are from very tiny fragments of the tail of Comet Tempel-Tuttle. Generally, it generates 10 to 15 meteors an hour in November. The Torrid meteor showers come in 2 installments. The southern Torrids come from mid-September to mid-November. The northern ones come from mid-October to mid-December. They average 5 per hour when they're coming down. They are tiny fragments from another comet called Encke. Okay, I'm going to switch subjects again, quite importantly, and we're going to introduce one of the 2 superheroes of this saga, both from Arizona. The first superhero is the biography of Gene Shoemaker. Born in Arizona, Gene thought a lot about the craters that existed on the moon and other bodies. In 1952, he made a long visit to Meteor Crater. It had been and still is a major tourist attraction. We spoke about it with the Barringers earlier. Total consensus that it had been formed by a meteor about 50,000 years ago. Now, in 1956, with the Cold War raging, Gene was with the U.S. Geological Survey. He was sent to study craters formed by small underground nuclear tests at Yucca Flats. He did seminal research on the mechanics of very violent impacts and discovered cosite, a silica produced only by very violent impacts. It is very common on asteroids, but very rare on Earth. We knew that it came from asteroids because there are tons of pieces of comets and asteroids all over the planet, and I'll talk about that a little later. He was extremely shocked by just how closely a lot of the geological characteristics of the Yucca Flats blast sites matched the geological characteristics at Meteor Crater. In 1961, he earned his PhD from Princeton. Can anyone guess what his thesis was? Meteor Crater. In 1961, he was immediately given the lead role at the U.S. Geological Survey in Flagstaff, Arizona. There is a very large telescope in Flagstaff, and we're going to hear more about that later. Gene invented a whole new field called astrogeology, a marriage of astronomy and geology. He badly wanted to be an astronaut, in 1963, but found he had Addison's disease. He did a lot of training of the astronauts in the Arizona desert. He was often on TV with Walter Cronkite in 1969, televising descriptions of the moon landings. Then Gene developed a new obsession, Earth-crossing asteroids. Think of 2 sets of railroad tracks that cross each other's path at one point in 3-dimensional space. Not 2-dimensional space, but 3-dimensional space. They occasionally will cross each other's path, some objects. How likely and when will they both be exactly in the same place at the same time? It is different for every comet and every asteroid, but extremely, extremely unlikely for any one. In 1969, he went to Caltech and started a systematic search for Earth-crossing asteroids. He was gradually going to displace the prevailing wisdom that almost every major geological change in the Earth came from volcanic activity and not deep impacts. We now interrupt our coverage of the life of Gene Shoemaker to address the formerly burning question: what caused the sudden extinction of the dinosaurs and most species 65 million years ago? When I was going to college in the late 60s and all through the 1970s and maybe into the 80s, there was no clear answer, but the consensus was very far from the theory that it was a catastrophic impact from a comet or asteroid that did this. Let me describe the key work of Gene Shoemaker and the Alvarez brothers at Berkeley to establish this. The Alvarez brothers dug at sites all around the world at a depth equal to 65 million years ago, all through the 1970s and into the 1980s. They found a layer of iridium all over the world at that depth of 65 million years ago, everywhere they looked. And we knew iridium was common in asteroids, but very rare on Earth. The width of the layer increased the closer you got to Mexico. The smoking gun to silence all the refuseniks and the naysayers was finally found by Pemex while drilling for oil around 1990. The Chesapeake Crater, at a depth equal to 65 million years ago, is under both the Yucatan Peninsula and the Caribbean at a size of 112 miles and circular. 112-mile crater and circular. Now, in March 2010, a group of 41 world scientists hopefully put an end to any other theories, and there's a little bit of false precision, might say, in this, but I'm going to quote what they had to say in 2010, and I'm going to go back and forth from direct quotes to paraphrasing. But I'll start with some of their quote. 66.043 million years ago, a 6.2 to 9.3 mile space rock hit the Earth at Chesapeake, causing the mass extinction of 66% of all species. The energy was 1 billion times the Hiroshima bomb. Another way that some have described, just to get, you can't even get your head around the energy of this explosion. It's just, it's beyond even understanding, but we'll try here. It would be as if we exploded all the nuclear weapons in the world at once, took that energy and multiplied it by 10,000 times. Okay? The immediate impact heated the entire atmosphere of the planet to 500 degrees Fahrenheit for 3 to 5 hours. Think of the entire atmosphere of the Earth as one big microwave, going to 500 degrees for 3 to 5 hours. Recent research suggests that the entire terrestrial biosphere may have been completely burnt out. Global firestorms resulted, which left a thin layer of debris all around the world, which can be found. There also were massive global tidal waves. Also, there was a long nuclear winter, which makes any nuclear winter nightmare we had thought about from nuclear war look really Mickey Mouse. The mass extinction seems to have happened over a 7,000-year period at most, which is really the blink of an eye when we're talking about geological time. Now, this giant crater is only the third largest we know of on the surface of the Earth. And after a lot of searching, it was only found in 1990. The two larger ones are the Vredefort in South Africa and Sudbury in Canada. They hit 2 billion and 1.85 billion years ago, respectively. They measure 190 and 160 miles. We know nothing about what consequences they may have caused in the history of our planet, but it must have been something. I'm going to stop at the sixth largest crater, the Acraman in South Australia, is 580 years old. It's found along a 185-mile-long strewn field. A strewn field is a long path of comet and asteroid debris along the path the object follows as it gets closer and closer to impact. And what's amazing about this one is inside this strewn field, they find fossils of first complex forms of life 580 million years ago. Number 7 is right in front of our faces, and we didn't even see it till 1983. The Chesapeake Crater. Yes, folks, Chesapeake Bay is right above a crater. It's about 35 million years old. It's about 53 miles. Now, obviously, we still have not found anywhere near all the craters that dot our planet. The most recent one is in the top 10 is called Beaverhead number 9 in Montana and Idaho, 600 million years ago. It was not found until the mid-1990s. Now, this next point has some controversy attached to it, but there is definitely evidence that leads some people to believe and some people to disbelieve that there was an even more important collision, perhaps 400 million years ago. The relative size of our moon is about 23% of the density or volume or size of the Earth. It's the largest moon in size relative to its parent planet. And a lot of the material on the moon is close to the material on Earth. And why do we have a 4-degree tilt on our axis? The theory is that the moon was created by a giant impact. Amazing. The Japanese, for their part, have been conducting large surveys in Antarctica via jet skis over the white ice. They have found materials, many materials, that definitely came here from the planet Mars. They did not get here by New Jersey Transit. Impacts on the planet Mars in the deep past must have been so incredible that debris was flung out that traveled all the way to Earth. And of course, there was the Great Bombardment, 1 and 2 billion years ago. Our two largest craters, bigger than Chicxulub, were about 2 billion years ago. It possibly seeded the Earth with the amino acids to allow life to begin on Earth. I will come back to that later. Now let me jump into a little soap opera here. Long after NEO got established in 1998, we thought we knew what we were doing. In 2004, a 300-meter comet was discovered at Kitt Peak, the Catalina Sky Survey. The early forecasts were for it to hit the Earth in 2007 with a 2.7% probability. The media attention went viral. The headlines were huge. Comet Asteroid coming to impact the Earth in only 3 years with 2.7% probability. Well, after a few weeks of further observation, it was found to be false. It was and is named Apophis, the Death Star. And after that, they became much more careful about releasing any information without extreme vetting. However, Apophis is worth a lot of attention. Apophis orbited the sun as predicted in 2007. It's a 7-year period item. It went around the sun in 2014. It went around the sun right now in 2021. And it's going to go around the sun in 2028. Now, starting in 2004, up until a few weeks ago, the expert prediction was after it goes around the sun in 2028, there's something called a keyhole, which is a very small little slot in reality in the space. So if it went through the keyhole, there was a 1 in 10,000 chance that it would have a 2036 deep impact on Earth. That was the conventional wisdom until April 2021. Newsflash. In April 2021, they had a chance to get much more precise measurements. Now it is clear that it poses no threat to the Earth for at least the next 100 years. Now, let's go back to Gene Shoemaker in 1993. Gene Shoemaker and David Levy were by far the most prolific comet hunters in the world. They discovered Shoemaker-Levy 9 in 1993. It was on a straight collision course with Jupiter in 1994. Shoemaker-Levy 9 was found by the greatest comet hunters in the world. Back then, the government did not spend 1 penny on looking for comets and asteroids. All the discoveries were made by individuals, by private people. Remember Hale-Bopp? That was discovered by Hale and Bopp. And it was visible to the naked eye longer than any comet since the Great Comet of 1811. That's a long period comet for 260 days. And even Gene Shoemaker and Levy almost missed Shoemaker-Levy 9, but they saw it. And en route to Jupiter, first, all the experts mocked Gene Shoemaker's prediction that it would pierce Jupiter's massive gravity and gas environment. Jupiter is, I think, 10,000 times the size of the Earth. Its gravity is massive. So it seemed laughable that this Shoemaker-Levy 9 comet that was headed for Jupiter was even going to get close or hit Jupiter. En route to Jupiter, Shoemaker-Levy 9 was ripped into 21 small machine gun pellets. Boom, 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 boom. It was ripped into 21 little pieces, each of them maybe a kilometer each. So obviously, nothing was going to happen. Well, for 5 days in July 1994, every serious telescope in the world, every organization was aiming its view at a very small part of Jupiter where the impact was going to happen, if anything happened at all. I sometimes like to be a little dramatic, but history was made. Boom! 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 Every one of the 21 little pellets had left a crater larger than the planet Earth or a fireball larger than the planet Earth. Boom! Get out of here. I got my wife's attention. Sorry, guys. Hey, anybody awake yet? Something should be done. And in 1994, our great Congress passed a resolution saying that 90% of all extinction-sized, 1 kilometer plus, Earth-crossing objects needed to be found. And they appropriated $0 and 0 cents. Many hearings were held. Many Nobel Prize winners testified. This was proven over and over and over again and existential from the entire human race. In 1995, what did Congress do? Nothing. In 1996, what did Congress do? Nothing. Now, this is going to be my first audio visual, and I don't expect you guys to have a good view of it, but in insurance and reinsurance and actuarial circles, this cartoon, which you may or may not see much of, became viral. And I don't know if it got into the Bell Labs ecosystem, but anyway, one dinosaur is saying to the other, all I'm saying is now is the time to develop the technology to deflect an asteroid. And the second sentence says, over their shoulder, a comet is heading for the Yucatan Peninsula. Effing nothing happened. Nothing was happening. It was a cultural thing, but nothing was happening. 1997, Steven Spielberg. I don't agree with his politics much, but he's a real stand-up guy. Steven Spielberg in 1997 released the movie Deep Impact, a very well-researched and very accurate description of what probably would have happened in 1997. And it's a great movie as a work of art. It's meticulously researched and very plausible. That's exactly what probably would have happened in 1997. Well worth seeing. And Armageddon in 1998, a second asteroid comet movie with Bruce Willis and other people. They both show how ignorant we were in 1998. Blowing up atomic bombs either on the surface or drilled underground into a comet or asteroid would be about the worst thing you could do. You would turn it into dozens or hundreds of objects, and they would be radioactive. My personal outrage was so great that I decided to lobby Congress personally. I joined the Republican senatorial inner circle in 1998 simply because they controlled the money and the budget. This was to be the most important thing I would ever do in my little life, no doubt about it. The meeting was held on October 1 and October 2, 1998. If you remember, there was a small distraction: the impeachment of Bill Clinton. The Starr report came out from Ken Starr in September 1998, and the official House inquiry was starting on October 8th. This was 1 week before the House impeachment began for Bill Clinton. Nevertheless, it was still the best government money can buy. This meeting was not for the K Street crowd or the powerful corporate or special interest lobbyists. It was for small farmers and ranchers and businessmen and people like me. My $5,000 got me 20 one-on-one 15-minute sessions with Republican senators. This is the only time in my life I was a lobbyist, even a minor one. I could spend 30 minutes just talking about this thing, but I will not. Ted Stevens of Alaska was different. If you wanted to get time to talk to him, you had to pay him extra money on the side. Not many people have gone from a seat in the United States Senate to federal prison, but Ted Stevens has. I had a meeting one-on-one with Senate Majority Leader Trent Lott. I'm maybe 3 feet from him for 15 minutes. I'm thinking to myself, here's a former old Miss cheerleader, male cheerleader with a bad toupee. Most said, good luck with that asteroid insurance, thinking I must be some sort of insurance industry lobbyist. My last visit was always my best hope. John McCain. Powerful John McCain from Arizona. He was then known as the Maverick. He knew Meteor Crater himself and quite a bit about comets and asteroids. There was no lobby for saving the human race. It got you nothing from the party or donors or special interests or corporate America or anybody. There was nothing in it for him. But I do not delude myself that I was the sole reason or even a major reason why he took action. I'll still repeat, this is obviously the most important thing I will ever do in my little life. He took action. In 1998, he championed the establishment of NEO, N-E-O, Near Earth Objects, inside of Jet Propulsion Laboratories, JPL, inside NASA, with the sole mission of detecting near Earth objects. It started with 2 people and a $1 million budget. By 2019, it had grown to a few dozen people and a $40 million budget, very minuscule by federal government standards. Yet all the staff are world-class astrophysicists. Virtually every NEO mission has achieved 100% or more of its objectives. How can a government program do that? Well, they always partner with either a major observatory or MIT or Caltech. Their very first mission, Near Earth Asteroid Rendezvous, NEAR, was an overwhelming success in 1999. It was only supposed to get very close, take detailed pictures and observations of an asteroid. It achieved 100% of all its objectives, and it got so close they decided to do the impossible and try to actually land on an asteroid. It did. Asteroid 433 Eros, the first time the human race had actually made a soft landing on an asteroid. It kept sending data, signals, messages, and measurements back to Earth for weeks. This was only the first of a long series of wildly successful missions that meet or exceed objectives, come in at or under budget, and on or ahead of schedule. Stardust was launched in 1999. It made a very close approach to Comet Wild 2. For the first time in human history, we collected in a net comet dust and landed it back in Utah on Earth. The research on this dust established that every single comet is unique with its own fingerprints. It also found the amino acid glycine in the comet dust. Glycine is one of the known building blocks for life to evolve. The Deep Impact mission in 2005, it was the first time we actually got in the path of an asteroid, looking it in the eye, launched a projectile at it, and observed and measured the crater we created. Not only did Steven Spielberg make the great movie Deep Impact in 1997 to try and warn us, he helped finance the Deep Impact mission in 2005 with his own money. You needed an impactor and an observer to relay all the data back to Earth. So you're sitting here, you fire the impactor at the comet, and you take measurements. It was another complete success. It found that water existed on the comet Tempel 1. It had a predicted crater it was going to create and a 3.6 degree deflection on the asteroid it was going to get. It actually achieved a crater exactly as predicted and a deflection exactly as predicted. It was so successful, they repurposed it for another mission to go out to Comet Hartley 2 in 2010. The Rosetta mission was launched in 2004. Rosetta landed on Comet 67P, which a bunch of Russian long names on it, in 2016. This was the first time the human race had made a hard landing on a comet. OSIRIS-REx. OSIRIS-REx was launched in 2016. This was the first time we ever had a hard landing on a comet. We were going to take samples of a lot of materials from that comet and return it back to Earth for further studies. By an incredible coincidence, and I didn't time this, OSIRIS-REx has just blasted off the surface of Comet Bennu yesterday. It's on its way back to Earth, and we know it has carbon and water and other things, and is expected to land here in 2023. Our best estimate is that Bennu has about 1 chance in 2,700 to hit the Earth in the 2175 to 2196 time period. At 500 meters, it is a continent killer. The Japanese have a perfectly parallel mission to the comet Ryugu. They're a little ahead of us. They're on their way back already. Definitely 2 of the most hazardous known Earth-crossing asteroids over the next couple of 100 years. Now let us discuss actual airbursts and impacts on the planet Earth. An airburst or a bolide or a fireball is an object that enters our massive atmospheric protection, remember the heat shields the astronauts needed, but explodes before it reaches the ground. These are much, much more common than actual impacts. Tunguska in 1908 was an airburst, but some of these have impacted the Earth. As I said before, the Chinese had found Halley's Comet long before we did. But Chinese records talk about a deep impact event in 1490 that killed tens of thousands of Chinese in, I'm going to butcher the pronunciation, Xiangyang region. There are thousands of eyewitnesses and reports of that. In Jordan, there is a 25-mile plain called the Middle Gong. There's a city in the Middle Gong, Tal El Haman. It used to sit there anyway. After 15 years of archaeological work, they are more and more convinced that this was the actual site of the biblical city of Sodom. The archaeologists found a major city there for many, many centuries, and then just around 1700 BC, right on the biblical clock time, it was suddenly destroyed, totally destroyed. And evidence from pottery and other objects mounts that the objects were destroyed in a very, very brief period of time with immense heat. No one came back to live there for 700 years. That also makes sense. They probably were bombarded with enough salt and sulfur to make farming impossible for centuries. Now I'm going to get the microscope and just start talking about things that have happened in the last 75 years. 1947, the Shikot-Alin, Siberia event, the largest meteorite fall since Tunguska. 10 kilotons of energy and 33 tons of fragments on the Earth. You can buy some of these fragments cheaply. I have. In Kansas, at Norton County, February 18, 1948, 1 ton of fragments. In Chihuahua province in Mexico in 1969, it could be seen for hundreds of miles, 2 tons of fragments. In China in 1976, 4 tons of fragments from a fireball that was visible the size of the moon at night. And very interesting, the 2002 Mediterranean event. An object was suddenly found entering the Earth's upper atmosphere. It could and was erroneously identified as a potential missile aimed at India or Pakistan. Both were within hours of a nuclear exchange. It took strong and vigorous intervention from both the United States and Russia to avoid a nuclear exchange between India and Pakistan. And Turkmenistan in 2008 was the first one where they actually could detect the impact spot before the impact and predict it. Now, it's only been about 10 or 15 years that NEO has been able to accurately predict the time and place, the exact time and place of a comet or asteroid hitting the surface. Even then, it's only a matter of hours or a day or two. This Chinese piece of junk fragment that's coming down here right now from the satellite, even they cannot predict where it's going to land. It's laughable, but you hear them say, well, it's about 2/3 probability it's going to land in the ocean. Well, it's 2/3 probability it's going to land in the ocean because 2/3 of the surface of the Earth is ocean. And to get down to really microscopic stuff, we get about 100 million tons of asteroid dust every day landing harmlessly on the surface of the Earth, protected by our atmosphere. How often have airbursts and impacts reached the Earth over the last 33 years? Well, thanks to paying more attention, we have some very good records concerning both frequency and severity. Okay, I think we're ready to show our first professional slide.
It's ready.
Okay, I was going to start talking anyway. So as you can see, taking a look at this very interesting and very descriptive graph, look at from 1980 or the year 1900 until 1998. We don't exactly have it, but how many things have we discovered before 1998? Just about 0. Then in 1998, when NEO is fired up, you see the exponential growth of discoveries taking off. And the most important part of this graph is the least graphic, the red block. Those are the 1 kilometer plus size rocks. Those are the extinction level event rocks. It's generally been the case, and this estimate hasn't changed in the last 50 years. We believe there are about 1,000 of them out there. In 1998, we had discovered 50. So in 1998, we knew we were 95% blind with respect to extinction level event size, Earth crossing comets and asteroids. Now in 2021, we have found 889. So this is the most incredible accomplishment imaginable. The human race has gone from being 95% blind in 1998 to being only about 10% blind now. As I used to say in my talks, we're no longer a sitting blind, deaf, and dumb sitting duck. The orange slide is the discoveries of 140 meter and plus to a kilometer objects. Those I like to call continent killers. And as you can see, we've discovered a lot of them. And of course, the blue is all. Okay. Okay.
We're on slide 2 at the moment. Let us know when you want to go to 3.
Okay. You're showing the one with the 5 histograms?
Exactly.
Yes. So I'll talk more about that a little later, but basically it shows you the 888 of a kilometer or more, and the 5,911 and the 4,400, those about 10,000 of the continent killers. And of course, we found much, much more of the very small ones. But let's go to the next one. Things get a lot more interesting when we go to the next one. When you go to the next one, and this is going to take a while to talk through, and there's an awful lot of information in detail here. They've got 8 colors. If you've got it up yet, I don't know if you have it up yet or not.
It's up.
Okay. So you can take a look there again, starting in 1995. Let me just take a look let me define the 7 colors you see over the years. 7 major observatories around the world, plus the brown all other category. Let's begin with the blue bars, which you see suddenly coming into existence in 1998 with NEO. That stands for the Linear Project. This was a very early joint venture between MIT and the Air Force and NASA. Before 1998, there was no NEO program at all. This White Sands, New Mexico observatory was run by the US Air Force and NASA on a voluntary basis. And as you can see, in 1998, its discovery rate exploded, and exploded again in 1999 and in 2000, exploded. And it was the dominant source of discovering, and these are strictly extinction level size rocks. These are 1 kilometer plus rocks we're focusing on. It was the heavyweight champ all the way until about 2004, 2005, if you take a look at it. But let me go through all the different categories. The next one is NEAT, Near Earth Asteroid Tracking. That was by Eleanor Helene, and you only see them really in the very early years. That was kind of minor, but she was a real pioneer. The red one is Space Watch, which was in concert with the Air Force again, and it was a very kind of hokey thing. As you see, it only really found things in 96 and 95. Then we get to Lonius. Lonius is at Flagstaff, Arizona. It's a major observatory there. And you see the yellow beginning to have some important contributions starting in 98 and going all the way to about 2005. Then in 2005, you have the green, the Catalina Sky Survey on top of Mount Lemmon outside of Tucson in Arizona. That was the heavyweight champion very clearly beginning around 2003, going all the way till 2010, maybe a little bit more. Then the purple is the Pan-STARRS. Now, it doesn't look like a lot of territory there, but as you see over the years, once you find the easier ones, they get harder and harder and harder to find. So it's not that we have less capabilities of searching for these things in 2010 or 2015 than we had in 2000. We just are having a very hard time because these are sneaky, sly, tricky ones to find. And even though Pan-STARRS is more powerful than anything else the human race has, and it starts picking up a few things in 2010, going to 2016 or 2017, you see it's only finding maybe 5 or 6 or 7 a year. And that's that. Now, in 2013, oh, I'm sorry, I'll go a little bit more good news. Well, I'll go to 2013. 2013, we found a way to say we can't see these asteroids and comets. They're so hard to see. We then put up something called NEOWISE. I is for infrared. We started searching for asteroids, not just in the visible field of reality, but in the infrared space. And as you see, a little bit in 2010, but in 2015, 16, 17, the little blue stuff, that's what NEOWISE is finding. And I've got more good news for the human race. High in the Andes desert in Chile, construction is well underway, which for what will be by far the most powerful telescope in history. It will be 3 times as powerful as Pan-STARRS. And I expect when it opens up in 2025, you will see a new jump in discoveries. I expect it. And furthermore, it'll be the first world-class survey ever in the Southern Hemisphere. Okay. Okay, I think we're ready to go on. Go on to the
You're all
next one or
set.
not? What do you think?
You're all set, Nolan.
Okay. Here, we're looking at talking about what happens to the less large ones. You take a look at the 140-meter objects. We see about 400 a year, roughly discovered every year from 2000 to 2013. Then at 2013, discovering objects of this size became the top priority rather than looking at the huge ones we were before. Notice how the discoveries jump up after 2013 from about 400 a year to about 550 a year. And we found about 30% of those objects, we think. Now, getting to the city killers, the real small, dangerous ones, there are countless millions of city killer size rocks in the Oort cloud and the asteroid belt. We have maybe found 3% of them. With city killers, we are playing Russian roulette with the human race. Over 95% of the human race lives on only 5% of the surface. And these things are so small and so dark and so hard to detect. We did start NEOWISE in 2013, and we may have been getting a little too sanguine. We got a wake-up call. We got a Valentine's Day card that we're queuing up from the cosmos, not on Valentine's Day, but the day after Valentine's Day, February 15th, 2013.
In space. On February 15, 2013, a small asteroid exploded over the city of Chelyabinsk, Russia. The shockwave from the explosion damaged thousands of buildings, and almost 1,500 people were injured by broken glass and other debris. The explosion was more powerful than a nuclear bomb, and it was so bright that it briefly outshone the sun. No one saw this giant space rock coming. At 60 feet in diameter, it was the largest thing to fall from space in more than 100 years. It entered Earth's atmosphere, traveling more than 60 times the speed of sound, and exploded into countless pieces. The biggest fragments were later recovered in Lake Chebarkul. And that's what happened on this day in space. On this day in...
Okay, just a little movie for you guys. So let's not get too sanguine. It came in under the radar. Even in 2013, with all our observatories, we didn't see it coming at all. And just like in June 30th, 1908, if the Tunguska explosion had occurred 12 minutes later, St. Petersburg would have been vaporized. This thing came so close to Chelyabinsk, a city of 1 million people. If it had come in about 30 seconds difference, it would have destroyed the entire city and killed tens and tens of thousands of people, and we would have paid a little more attention. It was very, very, very close. And to emphasize the obvious, the most dangerous objects are not the ones we have seen and discovered. They are the potential future ones we have not yet seen. Now, every 2 years, there's a global planetary defense conference exercise. Inside the site we're going to give you access to later, they have the 2015 and 2017 simulations of these exercises. And in 2021, they just finished another one of these exercises in 2021, and Mark Edelman was kind enough, or was lucky enough, that he just sent me the results of it just a couple of days ago. Their simulation came up with a war game with an object 35 million out in simulated space and simulated asteroid. They had 6 months lead time to the collision, and after a 4-day simulation employing every trick in the book that we have in 2021, we failed to prevent an impact that probably would have destroyed Prague. How random are these hits? Are these asteroid hits? Let's just take a look at a map of the entire globe, 2-dimensionally. Did we get there?
It's up.
Okay. You see the big red dot? That's Chelyabinsk. Every one of the yellow dots represents an airburst in the air that is greater than or equal to a Hiroshima bomb. Over this 33-year period, if you counted up those yellow dots, you'd get about 33 dots. So very much regularly, about one Hiroshima bomb explosion happens in the upper atmosphere every year. And the blue ones are, of course, less extreme. And if you have any doubt that we're being bombarded regularly on a random basis all over the planet, you don't have to spend too many seconds or minutes in front of this thing to see what's going on. And just for scale, if we could put a circle for the power of the Tunguska explosion, it would be a circle 6 times that red circle. Not that the destruction would go that far, but that was how much energy was released in 1908. Well, I'll leave with a quote from the late, great Gene Shoemaker. "We live in a cosmic shooting gallery. Hope I've interested you and maybe informed you a bit." Oh, last but not least, I'm sorry, Steve, show them the last, please.
It's up.
Please write down that website, anything and everything you ever wanted to know. And we have things that are at the postdoctoral level there inside of that CNEOS website. You can run, they have a 2015 simulation exercise. They have a 2017 simulation exercise. This stuff would give anybody but Alejo a headache to try and figure out what's inside of these things. But most of their exhibits, as Steve can attest and I can attest, are pretty user-friendly, and you can learn as little or as much as you want. Okay.
You were going to do the Shoemaker quote at the end. You interrupted yourself.
I'm sorry, did I leave out Gene? The late, great Gene Shoemaker. Quote, "We live in a cosmic shooting gallery," unquote.
Okay, if we have any questions, you know to raise your hands and we'll call on you in order. Looks like the first one up is Bill Tittle. Bill, you have to unmute.
Okay. Nolan, great talk. My question is about detection. I'm leaving with the message that we really can't technically stay on top of this. Is it a matter of money that if we spent more money, we could improve the detection system, or there's just too much of this coming?
Great question. We can never perfectly detect everything that's coming. That's hopeless. But before 1998 in NEO, we were doing nothing. We were doing nothing to detect. And all those graphs and all those charts, the point of which was to say is we are very busy trying to detect everything we possibly can, starting in 1998. And the most incredible proof of that is of the 1,000 dinosaur rocks that we pretty much know are out there that have our death certificate on them. And we only knew about 50 of them in 1998. We know about 889 of them today. So to extinction events, we have gone, detection has gone from 5% to 90%. And of course, we're building a bigger telescope in Chile, which will get us closer. So we're getting better and better and better and better at detecting. And that is the key, that's the crux. But Chelyabinsk shows you that on a city killer level, on that size, it is almost impossible to detect every single one that might show up. So we're doing a much better job than we used to. If we would have stayed the way we were before 1990, I can't believe we'd be that brain dead. Even if they didn't invent NEO in 1998, somebody would have invented something, I would think, you hope. But since we did have John McCain and we do have NEO, we are light years ahead of where we were in 1998. Is it perfect? No. Is it close to perfect? No. Is it good? Compared to 1998, it's great. And again, we invented NEO-WISE. Just in 2013, we finally started looking at objects we can only see with infrared detection. So we're getting even beyond any kind of visible light. And as the charts all showed, the more we discover, we found the easy ones. It's harder and harder and harder to find new ones because we've been trying very hard and we have been missing some. I hope that's a decent answer.
A quick follow-up question. Even if you detect an extinction event, I'm not hearing, well, then you do this.
Yes, it's called detect and deflect. I didn't emphasize that enough. Detect and deflect. Detect it, the earlier you detect it, the less deflection you have to have. I guess I didn't emphasize that enough. Thanks, that's a great seminal question. That's why the Deep Impact mission in 2010 was so important. That's the first time we got in the face of a comet. We fired an impactor, a missile at it, and we left a crater and a deflection. We wanted to try and get a crater the size of a football stadium and a deflection of 4.6 degrees. We actually got a crater the size of a football stadium and a deflection of 4.6 degrees. So we do know what to do if we see it and if we have time. You don't want to blow it up with nuclear weapons. You want, it's like pool. You just want to deflect it. And the further away you can see it, the further away you can impact it. It's just like pool or geometry. You just need a very small angle of deflection to make it miss. So we're working on detection and deflection. So no, you don't have to give up hope. Just because we see it doesn't mean that we're doomed.
Paul,
Yes. Yes, I'm unmuted. Three quick things. First of all, fabulous talk, very informative. And I thought I knew a lot about this subject before, and I heard your last talk, but I learned a lot today. Thank you. One quick point of fact: I think you'll find that the Alvarezes are father and son, not brothers.
Oh, thank
yeah,
you.
Yeah.
Thank you.
A quick question about your, I guess it was your last slide, one with all of the colored bubbles floating over the map of the world. Did you say that was actual data, or was that a simulation?
That's actual data. Thank you.
Okay.
That's actual data.
Good.
And
Yeah, that's fine. You were talking about simulations almost in the same sentence, so I just wanted to be clear.
yes, no, I was
Okay.
jumping a lot. I'm jumping
That's
around a
okay.
lot.
So-
That's
so-
actual data, and all the data that you see is updated on the website on a daily basis. All of those statistics are updated on a daily, and if you can go hover over that red circle or the yellow circle in the website, they will say, the red one is Chelyabinsk, Russia.
Oh, they're
It's
all
February,
active.
It's February
Oh, yeah.
13th, 2000.
That's
February
fab-
15, 2013. It's 20 kilotons. You can go hover over any of these little
wow.
real observations
That's great.
and be informed. I urge you to do so.
That's great. Now I have one tiny question of curiosity. This is not too fundamental, but I try to imagine a space shuttle going up to an asteroid and landing on it. And I know that these things are not very big, so there can't be much gravity. How do you land on an asteroid when there's almost no gravity? How much gravity is there on a typical asteroid?
In a typical asteroid, there's very little gravity. I am not a rocket scientist, but Gene Shoemaker and all the super PhD rocket scientists, they know when they're going to send a mission, the size of the asteroid they're landing on, what the gravitational power is of that asteroid, how they're going to go about, orchestrating the landing, quote unquote. They obviously know what they're doing because they've succeeded.
Maybe they put glue on their landing gear.
Well, maybe they did. Maybe they did.
I think
Okay.
it's actually some kind of a grabber. I mean, it seems like I read that.
Okay, great.
Yes, thanks, Mitch. Yes, some of them do have, they do protrude things to hook into. Thank you. Yes, that is one technique that is used to make sure they don't float away. I'm amazed at their, of course, you're talking about the greatest astrophysicists in the world, period. 20 or 30 of them working for this little operation, which is like a skunk works. And you guys know how great that can be. It's like Bell Labs to the 10th power.
okay, Alejo? Al, you have to mute.
Yeah, great talk, Nolan. I've been fascinated by asteroids and comets ever since I was a little kid, and your talk rekindled some of my youth. Since you were an actuary, here's an actuarial question. We know that our sun is going to cease shining and it'll destroy. It's an extinction event for humanity on the Earth. As an actuary, when do you think we should start worrying about this? And what do you recommend we do?
Well, as I said from the very beginning, when I talked about Tunguska, timing is everything. You know, are we talking about 12 minutes between vaporizing St. Petersburg and blowing up in the middle of nowhere? The insurance industry doesn't concern itself with events more than 1 or 5 or 10 or 50 or 100 years. I mean, and that's the kind of thing that we focus on. I've insured everything from the World Trade Center to the oil tankers in the Persian Gulf on a daily basis at Lloyd's of London. I've gone to insuring some of the most exotic, dangerous stuff you can imagine. But there's nothing in the insurance actuarial world that even contemplates contingencies more than 50 or 100 or 200 years out. Yeah, the sun will cause an extinction in a couple of 100 million years from now. And as I was saying to the guys when we were prepping for this, we could have a gamma ray burst that could wipe us out on any day. The sun could have a massive solar flare tomorrow and wipe us out. But this is the only extinction event that we can really do something about, really can mitigate it. Just like we've turned air travel from a dangerous activity to a safe activity. We have really reduced our risk with respect to extinction from comets and asteroids. And we can do better and we can do more, but it's really been, compared to what we haven't done with the environment and the greenies, what we've done in this has been remarkable in 23 years.
Thank you.
Yep.
Nolan, it's now 11:30. We have several questioners. If you could take a few more.
Nolan, thank you for the, can you hear me? You can hear me?
Yes.
Okay, thank you.
Yes, I
I'm
can.
using headphones. Okay. You mentioned the extinction event of 65 million years ago. I've always thought that the Gulf of Mexico had a suspiciously circular shape, which would be just about right for a huge asteroid. Do you know anything about the asteroid that hit in the Comet Trench, which is thought to be half of a semicircular trench about the deepest part of the Atlantic, about 3 miles deep or something like that?
I know
they
nothing.
think it was. Yeah, I'm sorry.
I know nothing about that. I know a lot about the Chicxulub crater. The Chicxulub crater is virtually circular. It's half under the Yucatan Peninsula and half under the Gulf of Mexico. If you go to the Yucatan, there are these wonderful little tourist things called cenotes, these perfectly round little pools of water that are part of the geology that comes out from the Chicxulub crater.
Okay.
The Chesapeake Crater is pretty much Chesapeake Bay, but the Chicxulub crater is not the Caribbean. It's partly in the Caribbean.
No, this was a different one. This would have been a more recent one that they thought was about 6 miles across.
Oh, no, it doesn't ring any bells. I'm sorry.
Okay. Never mind. Thank you. It was a great talk, by the way.
Larry Cunningham, you have to mute.
Yeah, hi Nolan, thanks. It was a very interesting technical, with a little technical to it. So my question refers to the concept or the techniques that they are talking about for deterring the object away from its path. Obviously, if it's a small item, it doesn't require much effort to move it, but on the same token, it might make it a lot more difficult to intercept it. Whereas if you have a much bigger piece, you can probably land on it, but then you need to have a missile, or you need to have some way of running rocket engines and pushing it out of the way. So I'm just curious how the technique changes with the size of the object.
Yes, it's very much important. Most important is how much time and distance you have. Obviously, the further away you can spot it and the further away you can get to it, the less you have to do to it to make it miss.
Okay.
That's one. And of course, you're right. The bigger it is, the harder the problem. And they have talked about, I didn't mention it, but excellent point you bring up. There are a lot of theories. They've never tried attaching a tractor beam and trying to pull it. That's been one of the things they've talked about. They haven't tried it in an experiment yet. they have had the deep impact where they did launch TNT, pretty significant charge of TNT into a pretty big asteroid and I'm sorry, comet, and got the deflection they wanted. That's why they run these war games all the time. And they just had this one in 2021. And if you go into the website, they'll give you all the software for the 2015 and 2017 simulations. And that's a challenge at the postdoctoral level to go through it all.
I thought that would be solved by Bruce Willis, wasn't it?
Yeah, that was, I mentioned Armageddon. That was the wrong thing to do. That was the worst thing. I think I mentioned it briefly in my talk.
Yeah, you did. I was just joking.
Yeah, I know. Yeah. Unfortunately, some people may believe it. No, but we were that
Stupid.
dim. We were that stupid that in 1997 and 1998, our two big movies said nuke them, and nobody said, "What are you, stupid?" They didn't say that.
Nice.
Now we know better.
Herb Waddell?
Nolan, thanks for another of your great talks. Is this stuff primarily existing in our solar system? Is it agglutinating? Is it aggregating? Or is it coming in from outer space? Or a combination of all?
Well, very, 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 very little is coming from outer space. Most of the asteroids are in the asteroid belt. They've been there for billions of years. And most of the comets are in the Oort cloud, way out in the outer side. And they've been there for billions of years. Some of the comets and asteroids are really just loosely put together clumps of a whole bunch of impacts that kind of stuck together. But most of them are just primordial material left over from the creation of the solar system. And they've been out there probably for billions of years, just spinning around, and 99% of them we don't care about. More than 99%.
Well, thank you.
Okay.
Greg Sweetra?
Hi, Nolan. Great presentation. I just wanted to go back to, I think it was 1908. You mentioned the White Nights in London and further south. I'm not sure whether I missed, but I thought you were going to say something more about that.
I might have, I could have. I wasn't sure how my time was going. I think I nailed the time about right. I could talk a lot more about a number of aspects of this, but it was common knowledge. I mean, nobody understood why in the summer of 1908, you had sunlight 24 hours a day all summer in all of Europe. And of course, now we know why. They didn't put two and two together. That's how powerful that energy was.
So that was from the Russian impact or the airburst?
Yes. Yes.
Okay, thank you.
Yes, indeed. Yes, indeed. Absolutely.
Okay, Mitch?
And let's make this one, unfortunately, the last one after Mitch has a chance. I do know that Mort and his team do have timely topics coming up, so I'm sorry, but let this one be the last one.
Well, thank you, Nolan. Just here's the Iowa guy talking to you. About 79 million years ago, the largest asteroid hit the North America, hit in Manson, Iowa, and it was a 2-kilometer rock, and it's got this huge crater, but you can't find it now. It's completely silted over from, all of the things that have happened in 79 million years. So people actually go there and they come into the little diner in town and say, where the hell's the crater? And you can't find it. Anyway, interesting little piece of trivia just to end up the thing, not a question. So close it out, say goodbye to everybody, and then we'll transition.
Okay.
Okay, Nolan, I guess this is up to me at this stage. I would like to thank you for a compelling and frightening presentation. Just when we thought we were out of the woods on COVID-19, we have a new fear to be concerned with. But seriously, you have opened our eyes, and we thank you for the role you played in helping to generate NEO. As you are well aware, With our speakers, we have a certificate of appreciation. I suspect that at this stage, you probably have enough of these to paper your family room. But please understand that each one of them comes with our thanks and our gratitude. And you also know the story behind the orchid that you see in the lower left-hand side, but we may have a few guests there who are not familiar. So briefly, back in 1930, when the Old Guard was founded, the city of Summit was at the epicenter of the orchid growing and distribution industry in the nation. And therefore, it was very logical for our founders to choose the orchid as our logo and as our symbol. And then, of course, if we could unmute everyone, we would like to give you the Old Guard salute.
Thank you.